All right, this video is going to go through the practice test 3. Most of them I will only do one problem out of the 2, so you can do the others later. Some of them I'll do both. You can always email me if you have any questions. So this first thing here is one of the note sheets. So that was the first page and the second page. We'll come back and use these as we go so I can show you where they're helpful. But this is the practice test. All right, so note the triangle might not be drawn to scale. That's a big thing to pay attention to whenever you're dealing with shapes, is that they could be off. You have to go by what numbers you're given, not what it looks like, okay? So that's a big thing to kind of focus on. All right, so now let's start. C, lowercase c, so it's a side, is 4, and angle A is 42 degrees. So from that angle, this is the opposite, this is the adjacent, this is the hypotenuse. I know 4 is the hypotenuse because it's across from the right angle, and A is the opposite because it's across from angle A, so that leaves the other one to be the adjacent. So if we go back to our sine, cosine, tangent, SOHCAHTOA was the easy way to remember that. That's going to help us here. So if we're looking for side A is the opposite, and we know the hypotenuse. So the one that uses O and H is sine. So sine is opposite over hypotenuse. So we're going to say sine of 42, because the angle always goes with sine. And then our fraction is going to be the opposite over the hypotenuse. Now, to get that fraction away, we multiply both sides by 4. So in our calculator, we're going to type 4 times sine 42 degrees. Now, we're dealing with a shape here. We're dealing with a triangle. So we want to make sure we are in degree mode, not radians. So we're going to hit the mode button, which is right here next to the second, and then go down to where your choices are radian and degree, and make sure you've chosen degree. Then if you hit second mode, it quits back to the main screen. And now we can type 4 times sine 42, and we get 2.68, because that other 6 is going to make that go up. So side A is 2.68. Now we're going to do the same thing for side B, but side B is the adjacent. So with the adjacent and the hypotenuse, we use cosine. So cosine of 42 equals B over 4. So we multiply both sides by 4, and we get 4 cosine 42. Plug that in the calculator, and we get B is 2.97. Then the last thing is angle B. Well, a triangle adds up to 180 degrees. So if we add the 42 plus the 90 that we already know, those are just the angles we already know, we get 132. And since the whole triangle has to add up to 180, I would subtract 132 from 180 and get 48. So angle B is 48 degrees. So now we know everything about that triangle. All right, let's look at number 2. So number 2, we've got cosecant and sine. Now, cosecant is the reciprocal function of sine, so they're going to undo each other. So you may recognize that they're going to be related. So the reciprocal is just going to flip this. So the answer is 9/4. Maybe you don't remember that, or you're not sure which one's which. So the other thing you can do is type it in your calculator. Cosecant is 1 divided by sine. And then in parentheses, you're going to do sine inverse, which is second sine. And then type 4 divided by 9 and close your parentheses. That'll give you 2.25, which is also 9 to the 4th. The third way you can do it is evaluate each piece separately. So start by doing inverse sine 4/9. And we get 26.388. And then cosecant is sine. So we're going to find the sine of that. So sine of 26.388 gives us 0.4444. And then we need the reciprocal of that. So 1 divided by 1 divided by 0.4444, and we get 2.25. So you can do it either way. You can do it piecemeal, one section at a time. You can just type it in the calculator. And then sometimes if you recognize their inverses and the related and reciprocals, you can do it that way. If we look at this one, cosine and tan are not reciprocals and they're not inverses. So we can't do the first way. So we can either just type it in the calculator or we can do it in pieces. So let's start with the just type it. Cosine and then second tan, 4 divided by 9, gives us 0.914. If I do it the other way, tan inverse of 4 over 9 is 23.962. Then I do cosine of 23.962. We get 0.914. So you get the same thing whether you do it piecemeal or not piecemeal. It doesn't matter. If your calculator was in radians instead of degrees for this problem, this number, like these two numbers, might be different along the way, but your final answer will still be the same. So for this problem, it doesn't matter which mode you're in. All right, number 3. Without using a calculator, so that's your hint to use the note sheet, find the exact value of sine -1 root 3 over 2. So we're going to go to our note sheet that has those values. So sine is root 3 over 2 at 60 degrees. So we find sine. I don't know why my pen's not working. We find sine. We go to the right over to root 3 over 2, and that's below 60 degrees. You gonna work now? Nope. There we go. Sine, root 3 over 2, 60 degrees. So that means it's positive at 60 degrees. But with sine, we need to be in quadrants 1 or 4. So 60 degrees is going to go with 300 degrees in quadrant 4. If you don't know that off the top of your head, oh, I lied. It's positive. So since it's positive, we stop there. 60 degrees or pi over 3. If it was negative, then we're going to go look at our thing and we're going to say, okay, 60 degrees is up here, so it's going to go with the 300 down there. And that would give us the relation by just looking at the picture. So you have choices of which way to do it. We'll do the other one too now that I messed that one up. Okay. Inverse cosecant root negative root 2. So we're going to look for cosecant and root 2 on the table. So cosecant root 2 tells us 45 degrees. This one was negative. So cosecant goes with sine. So we need to be in one of these. And it's negative in quadrant 4. So we could just write negative 45 degrees. Or negative pi over 4. Either of those is fine. If you chose to instead say, okay, 45 is here, so it's going to match the 45 one there, you could also put the 315 or the 7 pi over 4, because those are coterminal angles. So either thing is fine for that. The computer may not take both, but I will override it. So it's because I would rather you know that they're the same thing. So you can pick either option. All right, convert negative 2.3 in radians to degrees. So to go from radians to degrees, you're going to multiply by 180 over pi. So I'm going to do negative 2.3 times 180 over pi. So negative 2.3 times 180 divided by pi is negative 131.7. It says round to the nearest whole number, so negative 132 degrees. So that is a 1 through 4. All right, let's look at number 5. So number 5 gives us the unit circle. We know it's the unit circle because they tell us the radius is 1. And then it says point P is at 4/5 over 3/5. And then it wants us to find the 6 trigonomic functions. So sine, based on the rules we learned, also on our note sheet here, just in case you forget, sine is y. So sine is just going to be the y coordinate, 3/5. Cosine is the x coordinate, 4/5. Tangent is x over y, so 3/5 over 4/5. The 5s are going to cancel, so you get 3/4. The other functions are the reciprocals, so we're just flipping those. So sine goes with cosecant, so we flip that fraction. Cosine goes with secant, so we flip that fraction. Tan goes with cotan, so we flip that fraction. That's all we're doing. All right, 6 is another conversion problem. So when we go from degrees to radians, we multiply by pi over 180. So if I made that a fraction and multiplied, I would get 247 pi over 180. That's the exact answer. If I typed it in and rounded, I would get 4.31. So either of those would be fine if it doesn't tell you exact. And then radians to degrees, we multiply by 180 over pi. So 12 pi times 180 is 2,160 pi. 15 times pi is 15 pi. The pi's are going to cancel, and when I do that division, I get 144 degrees. All right, let's look at some graphs here. So cosecant goes with sine. So to get these numbers, we're going to get those from the sine and then go from there. So the stretch factor is the absolute value of a, whatever's in front. So the absolute value of -1 is 1. Period, we're going to divide by the number in front of x. But to make our life easier, we're going to factor that number out. So 4x divided by 4 is x. And then pi over 2 divided by 4 is like saying pi over 2 times 1 over 4. So we get pi over 8. So whenever we have both a phase shift and a period change, we're going to factor that out. Now to find our period, the period of sine is 2 pi, and we need to divide by 4, because that's the number we just took out, which reduces to pi over 2. So that's our new period. And then the phase shift is that number we just found. The negative tells us to go right, and we're going to go right pi over 8. All right, let's look at this one. So this one's tangent. So our stretch factor is the absolute value of a. So that's 2. We're going to do the same thing over here. We're going to divide out that 2. So 2 divided by 2 is 1, and pi divided by 2 is pi over 2. Now the period of tan is pi. So we start with pi, then divide by the number we factored out, and we get pi over 2. And then this is our phase shift. The plus tells us to go left, and we're going to go left pi over 2. So that's how you find that information from the equation. Now let's look at the graphs. So we have choices on these. We're going to go with the blue because the red one's dotted. That's how you can tell the difference. But we're going to figure out our information from the red one. So this graph, if I start at the origin, then I know I don't have a phase shift. Starting at the origin, this one goes down then up, so it's a sine graph. So our vertical stretch, let's start. Actually, it's easier to find the midline first. So if we find the middle of that sine graph, it's right here. That's at 2. We went up 2. So our midline is y equals 2. Then to find our vertical stretch of the blue, of the cosecant, we go from that midline to the top of our sine bump. So for this graph, that's 2. And our sine goes down first. So we want to keep that in mind later. And then our period, this one's not labeled, but it will be on the computer. So these would be pi, 3 pi over 2, 2 pi. So from the start to our finish of one sine curve is 2 pi. So that's the regular period. So to write our equation, we're going to choose cosecant because we used the sine curve. Our vertical stretch was 2, but we went down first, so we make it negative. There's no phase shift, and we have the regular period, so we're just going to do x. And then we went up 2, so that's what we're going to add at the end. Our midline is what's at the end. Let's do one more of those. So starting at the y-axis, to make my life easier, that starts at a minimum. So we're going min to min. So that's cosine, which means down here, the opposite of cosine, or the reciprocal of cosine is secant. The reason I know that's a minimum is because the middle of that red curve is right here. So that's at -1 because we went down 1 from the start. And those teal points don't go on the midline, so it's cosine. Our vertical stretch, so on here we're going up 1 to get to the top. So our vertical stretch is 1. Our period, so we start at 0 and we get back to the minimum at pi. So our period's regular pi. To find the number for the equation, we have to do 2 pi divided by pi, and we're going to plug in the 2. So now let's make our equation. So we said secant. We said our vertical compression was 1, but we went minimum to minimum, so that makes it negative. Our period changed. Our period was pi, so we need to put a 2 in there with our x. That's what we found right here. And then we stick our midline at the end, and that's the equation. We could do either of those. So I could have taken this same one here and gone from this max to this max, but that now adds a phase shift. So it's one less step if I can find the one that goes right on the y-axis. You can't always, but if you can, it's absolutely worth doing that. All right, let's look at number 9. Given an angle with the measure 49 pi over 10, find a coterminal angle between 2 pi and 4 pi, and find a coterminal angle between 0 pi and 2 pi. So, or between 0 and 2 pi. So 0 is just 0. We know that. We want to convert 2 pi and 4 pi to numbers over 10 so that it's a lot easier to see. So 2 pi, if I multiply by 10 over 10, is going to give me 20 pi over 10. And then 4 pi times 10 over 10 is going to give me 40 pi over 10. So now we know when we're dealing with it, we want this first one to be between 20 pi over 10 and 40 pi over 10. And then we want this one to be between 0 and 20 pi over 10. 49 is greater, so we're going to start with 49 pi over 10. And then to get coterminal, we have to subtract 2 pi. So I'm going to subtract 20 pi over 10. 49 minus 20 is 29. And 29 is between 20 and 40, so it works. Then 29 is not between 0 and 20, so we just do that again. So we take 29 pi over 10 and subtract 20 pi over 10, and we get 9 pi over 10. 9 is between 0 and 20, so we can stop there. Let's do this one too, just because it's negative, so it's slightly different. Not really, but slightly different. So same thing, 2 pi and 4 pi, but this time we want it over 2. So 2 pi times 2 over 2 is 4 pi over 2. So that's the limit for this one. And then 4 pi times 2 over 2 is 8 pi over 2. So let's start. We have negative 3 pi over 2. So a negative number is not between either of these. We're going to add our first 2 pi. And negative 3 plus 4 is 1 pi over 2. That does not fit in this range, but it is in between 0 and 4. So I'm just going to write that over here rather than do it again. We already found that one. To get to the next unit circle, we're going to add 4 pi over 2 again. And 1 plus 4 is 5. And 5 is in between 4 and 8, so we can stop there. So all you're doing is adding and subtracting 2 pi until you fall into the right range. If this were in degrees, you would just be adding and subtracting 360. All right. Suppose a circle has radius of 53 inches. Determine the length of the arc, so we're looking for arc length, that subtends a central angle of 76 degrees. So we know an angle, we know a radius, and we want an arc length. So I'm going to go back to that note sheet. Up at the top here, we talk about arc length. S is our arc length. Don't forget it needs to be in radians. And we know R and the angle. So if we're looking for S, this is going to be the easiest one. S equals R times the angle. So S equals R times the angle, but we need to turn that angle into radians. So to get 76 degrees to radians, I'm going to multiply by pi over 180. And if I put that in the calculator, 76 times pi divided by 180, I get 1.33. So now I have R and I have theta in radians. So I'm going to do 53 times 1.33. And I get 70.49 inches. Now, if you just typed that straight in the calculator without rounding here, like if you just did 53 times 76 times pi over 180, you would get 70.30 inches. So on the test, like when you send me your work, show me which one you typed in the calculator. Because if you give me this and I didn't do it that way and I didn't think to check it, I'm going to take points off because I'm not going to know how you got off. So even on the test, just writing this is enough to show me, oh, you didn't round. And if you write this, then I know you did, so I can check that part. That's helpful for me when giving you partial credit. All right, let's look. Number 11. A bicycle with an 18-inch diameter wheel is traveling at 7 miles an hour. Find the angular speed in radians per minute. How many revolutions per minute do the wheels make? So angular speed, I need to go look that up here. So linear speed is our speed on the straight path, V. So that tells me that V is 7 miles per hour. Angular speed would then be the W. And so we can get that with r theta, but we don't know an angle, so that's not helpful. We can get it with arc length and t. We don't have either of those information, so that's not helpful. So I'm going to bring this equation, V equals RW, and we'll use that when we get there. All right, so if we start number 11 here, we are doing a bicycle with an 18-inch diameter wheel is traveling at 7 miles per hour. So then it's asking us to find angular speed, find revolutions per minute. So the first thing we're going to do is we're going to get our 7 miles per hour into units that help us. We know inches and we know we want minutes. So we need to turn miles into inches and hours into minutes. So I know for miles that 5,280 feet are in 1 mile. So that cancels out the miles. Now I know that there are 12 inches in 1 foot. So that's going to cancel out the feet, and I have the inches I want. For hours, I know that 1 hour has 60 minutes. So that cancels out the hours. And now I just have to multiply these fractions together. So on the top, I do 7 times 5,280 times 12. And then on the bottom, I divide by 60, and I get 7,392 inches per minute. So now I have that in terms of the units that help me with my problem. So I'm going to go look over here, and I'm going to say, okay, linear speed is V, and that's the speed on the straight path. So that's what we just found, was V in inches per minute. Angular speed is what they're asking for. And so all I know is the diameter, which also tells me the radius, and the speed. So the only equation down here that's going to help me is V equals RW. So let's go back here. So V equals RW. If I'm solving for W, I need to divide both sides by R. So V over R equals W, which is the angular speed. And this is V. So if the diameter is 18, the radius is half of that. So the radius is 9. So V over R is going to be 7,392 inches per minute divided by 9 inches. The inches are going to cancel, and we will get 821.3 radians per minute. Now, I know the radians didn't come out. They came out of nowhere, but radians technically don't have units, so that's why you can just kind of stick it in there. All right, then we want to know how many revolutions per minute do the wheels make. So a wheel is a circle. A circle, or the circumference, is the distance around the circle, and the formula for that is 2 pi r. So to find the circumference of this circle, I need to do 2 times pi times 9, and I get 56.5. So that's how many inches are around the circle. So if I go 7,392 inches per minute, and I divide that by 565 or 56.5 inches per revolution, I would get 130.8 revolutions per minute. So really, you're just dividing the speed by the distance, and you get your revolutions per minute. So that's how you would do these problems. All right. Number 12, solve the triangle. That means find all the missing sides and angles. So if we know we're looking for angles, and we know we have a shape, we need to be in degree mode. So check for sure your calculator's in degree mode before you start. Mode, degree. Okay, so this one's good. All right. What do we know? Well, we know the angle and that side across from it. And then we know another angle. So we're going to be able to do law of sines here. So the first thing we're going to do is find the missing angle, because we know how many degrees are in our triangle. Sorry. So we're going to add the ones we know. 15 plus 20, and we get 35. And then we're going to do 180 minus 35 and get 145. So that gives us this one. Now that we know that angle, we can try to find this pair. So law of sines tells us sine of 15 over 7.5, that's our blue one, is going to equal sine of 145 over the side we're looking for. That'll give us x here. So we cross multiply. X equals 7.5 times sine 145. And we're going to divide by this other term, sine 15. Make sure we close parentheses in the calculator. Otherwise, you're going to end up taking sines of things you don't want to. So 7.5 times sine 145 divided by sine 15 is 16.6. So that's how long this side is, 16.6. So to do the other side, we're going to do the same thing. We're just going to use this pairing. So it's still going to be sine, calculator away, sine 15 over 7.5 equals sine of 20 over y, whatever that sign is. So if we cross multiply and divide, y equals 7.5 times sine 20 divided by sine 15, and we get 9.9. So this side is 9.9. So now we know all three sides and all three angles. That one's done. All right, we're going to go back into some trig here. Let's sketch some graphs. So in order to sketch a trig graph, we need the amplitude, we need the period, we need to see if there's a phase shift, and we need to see if there's a vertical shift or a new midline. So amplitude is the absolute value of A. So this is 2. Because it's cosine and negative, that tells us we're going min to min. Period of cosine is 2 pi. We need to divide it by whatever's in front of the x. So we're going to divide by pi over 3. When we divide fractions, we flip them. So we would end up with 6 pi over pi, which is 6. That tells me I need to change these 1, 2, 3, 4, 5, 6, 7, 8, just to make my life easier. Phase shift, there's nothing added or subtracted in the parentheses, so there's no phase shift. And vertical shift, there's nothing added or subtracted, so our midline is still 0. So this is our midline. So cosine's going to go min to min with a 2. So on the y-axis, we're going to go down 2. And then at 6, we're going to go down 2. In the middle, so between 0 and 6 is 3, we need our maximum. And then in between each of those, it crosses the midline. So at the 1.5 and 4.5. So that's one period of our curve. That's going to repeat, right? So 1.5 later, we're going to be here, and then our max, and then there, and then our min, and then there. And so the curve is just going to keep going on and on forever, depending on how much it asks you to show. Let's do a sine graph too, just for practice. So our amplitude is the absolute value of the number in front, so that's 3. So sine starts, it's positive, so we go up first. Okay. Period of the sine is 2 pi, so we need to divide by the number in front of x. So 2 pi divided by pi over 4 is like saying 2 pi times 4 over pi. 2 pi times 4 is 8. So we get a period of 8. So I'm going to do the same thing down here with my axis. Okay. Then our phase shift, what color was that, blue? There's nothing in the parentheses, so we're going to start there. And then our vertical shift is -2. So that means our midline is going to move down here. So sine starts at the midline. and ends at the midline. So period 8 is going to go back to the midline. And then the middle is also the midline. We go up first. So halfway between 1 and 4, which is 2, we're going to go up 3 because that's our amplitude. And then halfway between 4 and 8, which is 6, we're going to go down. So that's one period of our sine graph. If I wanted to repeat that, I would keep going down, back up, back up. Oops, that's not far enough. Back up, back down, and it would just repeat over and over again forever. So there's your trig graphs. All right, here's another triangle. So our hint already, degree mode. As soon as we see a shape, we want to make sure we're in degree mode. Let's see what they give us this time. This time they tell us that side A is 12 and angle A is 38. Oops, 38. So from that angle, C is the hypotenuse because it's across from that angle. 12 is the opposite, which makes B the adjacent. We're going to use our SOHCAHTOAs again. All right, so side C is H. We know O, so we're going to do sine. Sine of 38 equals 12 over C. To get rid of the fraction, we would multiply both sides by C. And then we would have to divide by sine 38 to get the C alone. So really, we're just going to switch these. Since we're multiplying one and dividing the other, we're going to change it to C equals sine, or 12 divided by sine 38. Type that in the calculator, 12 divided by sine 38, and I get 19.49. So that's C. Side B is A, so we're going to do cosine of 38 equals 12 over C. Same thing, we're going to switch those. So C is 12 divided by cosine 38, which gives me 15.23. And then angle B, triangles have to add up to 180. So we already have 90 and 38, which gives me 128. So then I do 180 minus 128, and I get 52. So now I know all of the parts of the triangle. All right, let's look at number 15. All right, let's look at number 15. So we're saying from 0 to pi over 2. Pi over 2 is 90 degrees. So that's telling us we're only in the first quadrant. So we're somewhere like this on our graph. Find the trigonomic functions based on the given one. So they tell us secant is 5 over 2. Secant is the opposite of cosine, so that flips cosine to 2/5 automatically. Now, using our unit circle rules, that means the y-coordinate is going to be 2/5. And because it's a unit circle, the radius is 1. So in order to find the other side, we can use Pythagorean theorem. So 2/5 squared plus y squared equals 1 squared. 2 times 2 is 4. 5 times 5 is 25. 1 times 1 is 1. Subtract that from both sides, and we get 21 over 25. Take the square root of that, and we get the square root of 21 over 5. That becomes our y-coordinate, which is also our sine. So to get sine to cosecant, we flip it. And then we have to get rid of the radical. So we multiply by root 21 over 21, and we get 5 root 21 over 21. So that's our exact form. Tangent is y over x, and the denominators are going to cancel, so they're the same. So it's really root 21 over 2. And then cotangent flips that. So just like cosecant, we're going to flip it. But then we multiply by the radical. So we get 2 root 21 over 21. That is the cotangent. Those are the exact answers. If it says exact, you have to do it that way. If it doesn't say exact, you can turn it into a decimal. So square root of 21, come out of the radical, divided by 5, is 0.917. So if I say sine is 0.917, cosecant is going to be 1 divided by 0.917, which is 1.09. And then cosine is 2/5, so that's 0.4. So tangent is 0.917 divided by 0.4, which is 2.29. And then cotangent is 1 divided by 2.29, so you get 0.44. So if it doesn't say exact, decimals are fine. If it does say exact, do the fractions that way. All right, number 16, reference angles. So those we're trying to find an acute angle based on the y-axis. So the rules for those are going to be in your note sheet. If you're in quadrant 1, you use the angle. If you're in quadrant 2, you do 180 minus the angle, and so on and so forth. So the first thing we need to do is figure out the quadrants these are in. So 246 is going to be in quadrant 3. So the rule for that is the angle minus 180. And if I do that, I get 66 degrees. Next one, negative 125. So I'm going to add 360 to that to find a coterminal angle. And that gives me 235. 235 is in quadrant 3. So I'm going to do the same thing. 235 minus 180. And I get 55 degrees. Then I have the reference angle of 137. So 137 is in quadrant 2. So the rule for that is 180 minus the angle. So 180 minus 137 is 43 degrees. So you just use those rules to solve the quadrants. All right, let's do a couple more graphs. All right, so this one's cotangent. So we're going to start by graphing tangent, because that makes our life easier. It says give exact answers, but that's what we've been doing all along, so that's pretty straightforward. Amplitude is the absolute value of A, so it's 0.5. Tangent's positive, so it's going to go up to the right. Period of tangent is pi. We need to divide by the number in front of x, so divide by pi over 2, which is like multiplying by 2 over pi. So I get 2 pi over pi, which is 2. So I'm going to change these. 1, 2, 3, 4, 5, 6, 7, 8. And then vertical shift is up 1. So that moves our midline to 1. Our period for tangent splits that in half. So we have 1 on each side. So our middle is still going to be at the origin. And we're going to go 1 in each direction to get our period. And then that would keep repeating. For our amplitude, we're going to go halfway between the dot and the period, and then we go up a half. And we do the same thing in the other direction. So do that for each of them. And then we kind of draw our shape. So that would be our tangent graph right there. To do cotangent, we everywhere where there's an intercept on the midline, we turn into an asymptote. And everywhere where there's an asymptote, we turn into a point on the midline. Then we just switch directions of those same points. We're just going to go down instead of up with the points that are already there. So it goes down, 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 down. That might be easier to see if I do it in a different color. So the maroon is the tangent graph, and the blue is the cotangent graph. On the test, if you do these, if the computer's awful and you want to do it by hand, that's fine. If you do it on the calculator and show me a picture, that's fine. You just need to send stuff to me. It's the best way for you to get credit. Okay, so this one's cosecant. So cosecant tells us is the opposite of sine. So we're going to do sine. Because I have a phase shift and a period shift, I'm going to divide that out first. So I'm going to rewrite this equation as, if I can get this to work here. Okay, I'm going to rewrite this equation as cosecant pi over 2, and then if we divide those by pi over 2, we just get 1s. So there's nothing in front, so our amplitude's 1. Sine goes up first. Period of sine is 2 pi. We're going to divide by pi over 2, which is like multiplying by 2 over pi. So I get 4 pi over pi, which is 4. So I'm going to rewrite these. Vertical shift is up 1. So our midline is going to be at 1. And then our phase shift, even though that's not there, is right 1. So instead of starting on the y-axis, I'm going to start to the right 1. So I'm going to start here for sine. Then we go up first, and our phase is 4. So we're going to go up, come down at 4. We have to do the middle as well. So those are our midlines. Then we're going up 1. So in between the two blue dots, we have to go up and then down. So that is 1 period of sine. So I'm just going to keep doing that. I'm going to do it a couple times here. So in between. All right, so there's, and I'll do it one more in the other direction. Right, we're doing 1. Yeah, 4. I'm going to brain cramp there. Okay, so there's a couple periods of sine. Now to do cosine, wherever it hits the midline, we're going to put an asymptote. I might have spread those other ones on the left out wrong. We're just going to ignore those and go from the original 2 I drew. Got excited. And then we just flip our curve. So the blue is going to be our cosecant graph. All right, so same kind of thing here. This one, the only difference is it's out of order. It doesn't really matter. The number right in front of sine is our amplitude. Because it's sine, we're going to go up first where it's positive. Period of sine is 2 pi. We're going to divide by 4, so we get pi over 2. So I'm going to leave these just like they are, pi over 2. Vertical shift, it's down over here, so we're down 1. So that's going to put our midline here. And then is the function flipped vertically? That's really just asking, is that negative? So no, we're still going to go up first. No phase shift. So sine starts at the x-axis. And we have to do the whole thing by pi. That's a whole lot to get in one little section. So I'm just going to change this to say this is pi, so this is pi over 2. I'm just changing the scale to make my life easier so that I don't have to graph an entire sine function in one little thing. So now pi over 2, so we're going to end there, middle here. And we go up first, but we go up 4. 1, 2, 3, 4. And we go down 4. So that's 1 period. And then that would just keep going. So skip 1, skip 1, skip 1. Skip 1, skip 1. So we're just doop, 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 doop. And that would be that. All right, let's look at number 19. Find the area. So we don't have a right triangle, but we don't know all 3 sides. So we're going to use the sine area formula. So that's 1/2 times one side times the other side times the sine of the angle in between. So here, 1/2, that's part of the formula. A is 21. The other side we know is 23. And the angle in between is 35. This is a shape, so we need to be in degree mode. And then we just type that in the calculator. So mode is still degree. 1/2 times 21 times 23 times sine 35 gives us 138.5 centimeters squared, because we're in centimeters. So there we go. That's how you do that one. All right, we're getting there. All right, given the equation, so same thing we've been doing. Amplitude is the absolute value of the number in front. Period of cosine is 2 pi. So we're going to divide by that number. It's already been factored out for us on this one. Horizontal shift is also called the phase shift. So that one's going right 4. And the midline is the same as the vertical shift. So y equals 2. All right, 21. If the sides of a triangle are 8 and 11 units, and the angle in between them is 37, obviously my picture is not to scale, solve the triangle. So we have side angle side. Right now, there's no way we can make proportions, so we have to start with law of cosines. Law of cosines. So if we call this x, if we call this x, we're going to say x squared equals the 2 sides squared, and then minus 2 times both sides cosine 37. So that's the formula for law of cosines. Then I'm going to just plug all of this in the calculator. So I get x squared equals 44.44. Take the square root, and I get 6.67 for that third side. Okay. Now we can do law of sines to find the other ones. You could do law of cosines again, or you can just do law of sines. That's completely up to you. What we're going to do here, though, is I advise always finding the smaller one first. It just makes life easier. Just find the smaller angle first. So across from 8 is our smaller angle. So sine of 37 over 6.67 equals sine of our angle over 8. So we cross multiply. So 8 times sine 37 divided by what we know equals sine of x. If I type that in the calculator, I get 0.7218 equals the sine of x. And to undo sine, we do the inverse. So on my calculator, I'm going to type second sine 0.7218, and I get 46.2 degrees. So that means this is 46.2. And now we know how many degrees are in a triangle. So 180 minus 37 minus 46.2 is 96.8 degrees. That's this one. All right, we're going to do the other one because it's a little bit different because we start by finding an angle. So we need at least one angle to do law of sines, so we have to start with law of cosines. This is the angle we're going to look for. So 16 is going to be the number by itself over here. So then we do the same formula, 22, 8, but this time our variable is in with the cosine. So first, I'm going to get rid of all the squareds and all the parentheses. So 16 squared is 256. 22 squared is 484. 8 squared is 64. And 2 times 22 times 8 is 352. Now I'm going to combine like terms. So 484 plus 64 is 548. I'm going to subtract 548 from both sides so that I can get the cosine term alone. Now I'm going to divide by negative 352 to get the actual cosine alone. Now I do inverse cosine. So second cosine, 0.8295, and I get that x equals 34 degrees. Now I can do law of sines. So again, let's start with our smaller angle first. So let's say sine of 34 over 16. We're going to do the smaller one first. So sine of y over 8. Cross multiply. 8 times sine 34 divided by 16 equals sine of y. So I get 0.2796 equals sine of y. And then if I inverse that, I get y equals 16.2 degrees. And then to find the last one, I do 180 minus 34 minus 16.2, and I get 129.8 degrees. So combination of cosines and sines helps get it done. All right, we have another triangle, so we know we want to be in degree mode. Find angle Q. So when you know two sides and you're finding an angle, we're going back to SOHCAHTOA. So again, SOHCAHTOA is just a way to remember. Q is the angle we're looking for. So this is going to be the opposite, and this is going to be the adjacent. The ones that use those is tangent. So tan of Q is going to be opposite over adjacent. To undo tan, we do the inverse. So we just put the fraction in our second tan, type that in the calculator, and I get 34.4 degrees. All right, let's see what we got here. Which of the following is the graph of this equation? So let's find our things. Our amplitude is 3, and it's positive, so we're going to go up to the right. That automatically cancels these two because those go down. Our period is pi, nothing's changed. Our horizontal shift or our phase shift is right pi. And our vertical shift is up 2. So we want to find the middle of that curve. So we could be, on this one, it looks like it hits 2. On this one, it does not. So that one's gone, and this is the one that's left. So it's just using those rules. So this one, cosecant, goes with sine. So we're going to kind of think about sine while we're doing this. But let's see. So our amplitude is absolute value of -1. So that's 1. Our period is going to be 2 pi divided by pi, which is 2. When I divide that by pi, our phase shift is right 1. And our vertical shift or our midline is down 1. So the first thing we want to do is find the middle of these curves. So that's in between the up bumps and the down bumps. That's -1. That could work. In the middle of these, it's right here. That's +1. So that's not going to work. In between these curves, that's -1. So that could work. And then in between these curves is -1. So that could work. So we've used our vertical shift. Now let's look at our period. How far is it from bump to bump? So this one goes from just before 2 to 8, so it's 6 point something. This one goes from 0 to 6 point something. And this one goes from 0.5 to 2.5. Our period's 2. So that's too far, right? If we were going 2, it would be from just in front of the 2 to just in front of the 4. That's too big of a period. Same thing, that's too big of a period, so this is the one that's left. Because I didn't divide it out, just quick to show you, if I divide pi out, we get x minus 1. That's how I got my phase shift and then 2 pi divided by pi is 2. All right, 2 more questions. Find the area when the triangle has side lengths of 4, 7, and 9. 4, 7, and 9. So we know the 3 sides, so we're going to use the Heron's formula, which is the one with S times S minus A times S minus B times S minus C. This is on the note sheet. First, we find S. So we add the sides together and divide by 2. So I get 10. Then I plug it into the formula. So wherever I see 10, S, I'm going to put 10. And then I'm going to use the 3 sides. So one side is 4. One side is 7. One side is 9. Then I'm going to plug that in the calculator. So clear, big square root, 10, and then parentheses, 10 minus 4, parentheses, 10 minus 7, parentheses, 10 minus 9. And we get 13.4. And that's that. So if you know all 3 sides, Heron's formula works pretty good. All right, if cosecant of theta is negative 7 over 8 and the terminal side is in quadrant 4, find tan. So quadrant 4 means we're over here. Cosecant is the opposite of sine, so that's y. So that means this is going to be 7/8. On a unit circle, this is 1. So first we can find x. That will be helpful. So to find x, we do 7/8 squared plus x squared equals 1 squared. So 49 over 64 plus x squared equals 1. Subtract that, you get x squared equals 15 over 64. So we take the square root, and we get root 15 over 8. Tangent is y over x, so it's going to be 7/8 over root 15 over 8. The 8s are going to cancel, so we get 7 over root 15. And then multiply by root 15 over root 15, and we get 7 root 15 over 15. And it's negative because this is negative. If I put that in the calculator, if you didn't do it exact, you'd have negative 7 times the square root of 15 divided by 15, which gives us negative 1.807. On the practice test answer key, I have the reciprocal of that. I actually did cotangent. I realized I put x on top. But this is the real answer. So that is the practice test. Let me know if you have any questions, and good luck.